Today we're going to be talking about how to write equations in different forms. So we've talked about slope-intercept form, which we're going to talk a little bit about at the bottom of these notes as well. But we're also going to talk about point-slope form and standard form. So personally, I think that slope-intercept form is the most useful. So if given the choice, I would always put it in slope-intercept form, but sometimes you will be required to put it in these different forms. So uh, point-slope form the point slope form is just this equation right here. And you will never have to memorize these equations. It'll always be given to you. This is useful if you're given a point and a slope and you want to write it into an equation. But we talked yesterday about how to do that in slope-intercept form. And the slope-intercept form way that I showed you is much quicker and easier. But this is just another way to do it. So if you're putting it in this way, your y value is going to go here, your x value goes here, and your slope goes here. Your y and your x will stay in the equation. So it says x1 and y1 are points given to you. Later on, we're also going to put something in standard form. I've mentioned standard form once before, but we didn't really do anything with it. We just turned it into slope-intercept form. This time we're going to be putting it in standard form. So some things to know, it's always going to look like some number times x plus some number times y equals some number. So your x and your y's are always going to be on one side, and your non-variables or your constant is always on another side. Your a, so the number in front of your x, must always be positive, and you can't have any fractions in the equation. So just some rules. Your variables need to be on one side, your constants on the other. The number in front of your x needs to be positive, and you can't have any fractions. So the first two examples, we're just going to put it in point-slope form, which really doesn't take that much effort. We're just going to plug our numbers into this equation and almost be done with it. So you have y minus my y value, which was -2, equals your slope, which was 1/4, times x minus your x value, 3. So I just plugged in my numbers into this formula. Plugged in my y value for my y1, my slope for my m, and my x value for my x1. Once you have that, we're not going to do much simplifying because I still want it to look like this basic format, but I don't like seeing minus and negative. So I'm going to turn this into y plus 2 equals 1/4 times x minus 3. And that's all the simplifying that we're going to do, because like I said, I want it to be in this form. So the useful thing about this is if you are given an equation like this, you can quickly see, oh, the slope was 1/4 and it went through the point 3, -2. So that's really, in my opinion, the only useful thing about point slope form. So number 2, doing the same thing. Y minus your y value, which was 1, equals your slope times x minus your x value. And the only simplifying I'm going to do is I don't like that minus negative, so turn it into a plus. And you're done. Now the next two examples, we're going to be putting it in standard form. That, in my opinion, takes the most effort. So if you find standard form easy after we go through the examples, or you understand it at least, then you're set for this section. So remember, we want to get our x's and our y's on one side, no fractions, and the number for your x can't be positive or negative. So we're going to simplify this first by doing the distributive property. So you get y plus 7 equals -5x minus 15. Now you can start moving any term you want. I personally like to move my constant first, so move the 7 to the other side. So I'm going to subtract the 7 from both sides to get y equals -5x minus 22. And then from there I just need to move my 5x over, so I'm going to add it to the other side. And I like to always write the x first because it's alphabetical, so 5x plus y equals -22. So I'm going to check my three things. First thing, I need to make sure that my x's and y's are on one side and my constants are on the other, which they are. I need to make sure no fractions, so that part's good. And the number of my x needs to be positive, which it is, so I'm done. Now this next problem is going to be quite a bit more difficult because we're going to have to deal with some negatives and also have a fraction involved. So I'm going to do the distribute property first to get y plus 2 equals 5/3 times x is 5/3 x. And 5/3 times 6, if you can't do that in your head, just work it out on the side. 5/3 times 6, which is 6 over 1. So you get 30 over 3, which is 10. So I'm going to write plus 10 right here. So the quick way to do that, you just multiply your numerator times this whole number 6, and then divide by the denominator. So I'm going to start getting all my terms on the sides that I want, so I'm going to subtract 2 from both sides to get y equals 5/3 x plus 8. And then get the x to the other side by subtracting it. So we get negative 5/3 x plus y equals 8. Now some people have noticed, hey, I have a fraction, which I can't have, and I also have a negative in front of x, which I can't have. I'm going to get rid of the fraction first. The way to get rid of the fraction is to multiply every term by your denominator. So I'm going to multiply every term by 3. When you multiply negative 5/3 times 3, your denominators just go away, and you're left with negative 5x plus y times 3 is 3y equals 8 times 3 is 24. So I'm looking pretty good. I have my x and y on one side, constant on the other, no fractions, but I still have a negative in front of my x, which I can't have. So the way to get rid of that is pretty simple. You just change all of your signs. So it becomes a positive 5x minus 3y equals negative 24. So it's like dividing all of your terms by negative 1. So that's your final answer. So again, with standard form, just make sure your variables are all on one side, no fractions, and the number for your x needs to be positive. The last two examples are pretty easy. We just need to put them in slope-intercept form, so we need it to look like y equals mx plus b. So I'm going to do the distribute property here to get y minus 10 equals 4x plus 24. So I want to get y by itself, so I'm going to add 10 to both sides. Do not add the 10 to the 4x because those aren't like terms. So we get y equals 4x plus 34. And you're done because it's in slope-intercept form. And last one, no distribute property, so I just need to get y by itself by adding 9 to both sides. So we get y equals x plus 13. And we are done. If you have any questions, please let me know.